Okay, we're back again, and we're still working on lesson 41. We're doing lots of examples so that hopefully you will be better equipped to do your homework. This one is a cotangent. So we haven't done a cotangent yet. Cotangent, remember, is because it's the flip or the reciprocal of the tangent, it is the cosine over the sine. And 17 pi over 6. Where is 17 pi over 6? Well, this is 6 pi over 6 and 12 pi over 6. So we just throw away minus 12 pi over 6 because that's a full 2 pi and we can get rid of it. So when we do that subtraction, we have 5 pi over 6 left. So 5 pi over 6. And the sine of 5 pi over 6. Well, where is 5 pi over 6? It's going to be right over here. It's going to be a 30-degree reference angle because all of our pi over 6's are. And we're going to say, okay, what is the cosine of that angle? First of all, the cosine would be negative because it is to the left. So the cosine will be negative. The sine will be positive of that angle. All right, so here's my 30 degrees. The cosine is the long one, so it's going to be square root of 3 over 2. The sine is the short one, so it's going to be 1/2 on our unit circle. And that's going to evaluate this one right here. So we're still going to simplify that by multiplying by 2 over 1, 2 over 1. Same thing on the top and the bottom. That's going to clear out our fractions, and we're going to get a negative square root of 3. And we come over here and look at this next part over here. And we've got all of this. So we say, where is 9 pi over 4? Well, 8 pi over 4 would have been 2 pi. So we're going to be able to get rid of, but not only it's a negative 9 pi over 4. So let's get rid of the 8 pi over 4. So this is the same thing as minus pi over 4 when we subtract the 8 pi over 4. So we've got the cosecant, which is 1 over the sine, and we've got this negative square root of 6, and this becomes the negative pi over 4. So let's just jump down here, negative square root of 6, and the cosecant is 1 over the sine of a negative pi over 4. Okay, so now, let's move this down a little bit. There we go. So now this one is going to become a square root of 2 over 2, but since it is here, this negative pi over 4 is right here, it's going to be a negative square root of 2 over 2. So this is negative square root of 6 and a over square root of 2 over 2 negative. Okay, so then when I go ahead and flip that bottom one and multiply, the negative divided by the negative will give me a positive, and we'll have the square root of 6 times 2 over the square root of 2. And when I multiply by the square root of 2 and the square root of 2, that 2 will cancel that 2, and I will end up with the square root of 12. Okay, and the square root of 12 is not simplified. The square root of 12 is the same thing as the square root of 4, square root of 3, which is 2 square root of 3. So then I have this 2 square root of 3 over here, and this original was a negative square root of 3, and I am putting them together. Notice I already had my minus sign taken care of, so I'm just going to be adding these two quantities, and since I have a negative square root of 3 and a positive square root of 3, 2 square root of 3, when I add them together, I will get a negative square root of 3 plus a 2 square root of 3 is a square root of 3, and that is the correct answer. Okay, so now we're going to move over here to permutations, and permutations are very important because they're talking about the number of ways that something can happen, and when we're talking about permutations, we're talking about order mattering. Order does matter in permutations. So this is our formula for permutation. So it's talking about how many ways we can do something when order does matter. So the way I always remember this is the combination locks that we had when we were in school. I don't know what they call them now, but combination locks are misnamed. They should have been called permutation locks because order definitely matters on those. Okay, so here we have 12 things taken 4 at a time. Okay, so this is going to be 12 is the complete number. It's going to be 12 factorial over the 12 minus 4, or 8 factorial, which is basically going to be, let me pull this up here. Let's see, can you see that? So it's going to be 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, dot, 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 over 8, 7, 6, 5, 4, 3, 2, 1, and there we go. This factorial will cancel. Everything in here is going to cancel, and we will be left with 12 times 11 times 10 times 9, which we could do on the calculator, or we could cheat and look in the book and see that the answer is 11,880. 11,880. Okay, now what this is the same as is when we were doing them without a formula, we would say, okay, if I had 4 slots, 4 seats in a car, and I had 12 people that wanted to get in the car, okay, but it mattered which order they went in. Okay, so then how many ways could I put 12 people in this car in a specific order? Well, if this was the first seat, I could have 12 different people sitting in that seat. And then once somebody planted themselves there, I would have 11 people left to sit in this seat. And once somebody sat there, I would still have 10 people on the roster trying to find a seat. And then after one person sat there, I would have 9 people to choose from. So that's how many ways, 12 times 11 times 10 times 9, ways that 12 people could get into a car in a specific order, or if you were going to put people on a panel or whatever. But this permutations is when order does matter, and so that's the type of thing that we're doing there. Okay, now the next thing we're going to do in the next video is work on some homework problems, so I hope that you will have your homework paper out when we start again.